Okay, so if we look at this table of proportional relationships, first of all, maybe I should turn the thing on. Yes, sir.
Do you have any 0.5 left?
I don't. I'm sorry.
It's on. It's on.
Is it on? Okay. I mean, I have a pencil you can borrow. E-money if you want to borrow this one. I think this is point.
No, I have this one. I just have like half a string.
Okay. This is 0.9.
Can I sharpen my pencil?
Yeah, right. Okay, so somebody tell me, what is a proportion? What does it mean? Equal what? Two equal, anybody? Rhymes with ratios. Two equal ratios, okay? If I have unit rates that are equal in two ratios, does that also form a proportion? Yes, right? Okay. So if I look at these two examples, okay, and I want to see if these form a proportion, okay? Okay, these are two different rental cars, right? The first one is $19.99 per day with no other fees, right? So could I easily figure out how many, if I wanted to know how much 4 days would cost me, I could figure that out, couldn't I? Okay. What about the other one? This one has a fee of $9.99 plus what? $14.99 per day. Now, is that going to be a fee of $9.99 every day or just at the start? Just at the start, okay? And then every day after there, it's $14.99, okay? Now, do you think you could use a table to find out how many days it would take for these to be equal? You could, right? Okay, so let's take a look. We're going to look at how we can do that. Okay, here's your objective. Okay, if you will write your objective, please. Okay, all I want you to write is recognize and represent proportional relationships. Recognize and represent proportional relationships. This right here is what I want you to write. Okay? Okay, everybody got it?
No.
Okay, let's take a look at the next slide and introduce what we mean by using a table. Okay, we'll talk about proportional, non-proportional, and constant proportionality. We're going to find out, you understand what proportional and non-proportional mean. We're going to find out what a constant of proportionality means, okay? We'll look at that in just a second. Okay. Okay, so if I have, somebody read that question for me. How? Read that for me. Savannah, will you read that for us?
How can organizing information in a table help you determine if the ratios between two quantities are equivalent?
Anybody have any idea how we can do that? Okay, well, we're going to try it. So obviously this question is going to have to do with pizzas, right? Because there's a picture of pizza. Okay. All right. Miss Spencer orders pizza for her students at the end of the year to celebrate reaching certain milestones. Each pizza costs $7. Okay. So this is pretty simple, right? If she has one pizza, it's $7. If she has two pizzas, it's $14. If she has three, it's okay. How can I use this to figure out how much a certain amount of pizza? Let's say she had 10 pizzas. How much would that cost? Everybody tell me. 1, 2, 3, go. 70. Why? Because what did she do here? She multiplied every pizza. No matter what, every pizza costs how much? $7. Good. All right, so let's look at the next one. So if we put this into a table form, number of pizzas down here would be the cost would keep rising as the number of pizzas went up, right? Okay, now this year, the following year, Miss Spencer's orders pizzas again. In addition to each pizza costing $7, there's now a $2 delivery charge. Okay, so this one is, if we just put a number in here, if I said how much is 5 pizzas going to cost, okay, you could figure it out, but it's not going to be as easy and cut and dry like a table, right? Why did the first pizza cost her $9, but this one went up $7? Why did it only cost her $7 after that? Why do you think? You only have to pay the delivery fee one time. Does it matter how many pizzas come? No, right? Does that make sense? Okay. So how can I figure out how much 5 pizzas would cost? What would it be, Jacob?
Multiply 7 by 5 plus 2.
Okay, and 7 times 5 is 35. plus the $2 delivery fee would be how much?
37.
$37. Okay, so you could figure out how much would 10 pizzas cost? 10 pizzas, how much would that cost, Chase? $72. He multiplied 10 times 7 and then did what? Added 2, right? Okay. All right, so let's look at this first example. Okay, we're going to put this into a table form. Okay, Carrie earns $8.50 an hour babysitting. Okay, is the amount she earns proportional to the number of hours she spends babysitting? Well, what do you think? Think about this, guys. Proportional means if 1 hour is $8.50, how much does she earn after 2 hours, do you think? What would I do to figure that out? Multiply $8.50 times what? And that's going to be the same. There's going to be the same amount. If she spent 10 hours babysitting, what would I do to figure out how much she earned? Multiply 10 times what? $8.50. That's the same. Every amount of hours is going to be the same amount per hour, right? So if we take a look at this, we have a table. Okay. So 1 hour would cost $8.50. 2 hours would cost $17. 3 hours would cost $25.50, or she would earn, sorry. 4 hours would earn $34. Does that make sense? Okay. And all we did was put that into a table form, right? Okay, now we find the unit ratios. What does that mean? Well, we're going to take, if we flip it over, she earns 8.5 or $8.50 for 1 hour, right? Right? For $17, that's how much she earned over 2 hours, right? Agreed? Okay, which goes back. This can simplify down to what? 8.5 for what? 1 hour. If she earned $34 in 4 hours, how could we simplify that? If we simplified that, what would that be? Would it still go down to $8.50 per hour? Would it? Yeah. If you were to divide 34 by 4, you would get $8.50 or 8.5, right? That's per hour. Okay? All right. So let's take a look at this next one. Okay? Let's see if you guys can figure this one out. We're going to talk about it first. Okay, somebody read that problem. Somebody read it to me. Anybody? Brooklyn, read that for us. I think it's Katie. I don't know.
Can read 15 pages of her chapter book in 15 minutes. The table shows the number of pages she reads in 15, 30, and 14 minutes.
Okay. So what is this saying? That she can read 15 pages of her chapter book in 40 minutes. So every 40 minutes, how much does she read? So after 80 minutes, she should have read 30 pages. After 120 minutes, she read 45. This one's going up by how much? These are increasing by how much? By 40. And these are each increasing by what? Okay. So if we look at this and say, is the relationship between the number of pages read and the number of minutes spent reading proportional? Is there a proportion there? In other words, if I said she has been reading for 115 minutes, could you figure out how many pages she read? Yeah. How?
Multiplying by 15.
Right. And how many 40-minute period or how many 15-minute periods are in 115 minutes, which would be 5, right? And every 15 minutes, how many does she read? 40 pages. So what would we multiply? 40 times 5. So after 115 minutes, how many pages has she read? What's 40 times 5? 2, 0, 0. What is that? 200 pages. Okay, good. Did that kind of make sense? Okay. All right, now look at this next one. Okay, this is a little bit trickier. Okay, two quantities are proportional if the ratio comparing them are equivalent. Okay, so that first one we saw was $7 per pizza, right? So after 4 pizzas, it was $28. No matter what, this thing down here always stays the same, right? Does it matter if she orders 100 pizzas, is it still going to be $7 a pizza? Yeah. Yep. Okay. All right, so what that means is that number always stays the same. Okay? It's constant. What does constant mean? The same thing happens over and over again, okay? So if we look at the second one, she paid $9 for one pizza. But for two pizzas, she paid 16. Which, if you paid if you paid $16 for two pizzas, how much was each pizza? $8, right? I mean, technically it was $8. If she paid $23 for three pizzas, each pizza was $7. Okay, are these numbers down here the same? They're changing every time, right? For four pizzas, she paid $30. She paid $7.50 a piece, right? Right? Okay, so those are different. Those are not proportional, right? Does that make sense? And why are they not proportional? Because she had to pay that what fee? The $2 delivery fee, right? Okay, which made them all different. Okay, so let's look at this one. Okay, if we have this table, sorry, it's taking a long time to load today. Okay, a ticket agency charges a $6 service fee on any order. Each ticket for a concert costs $25. Okay, is the cost of an order proportional to the number of tickets ordered? Okay, how much is one ticket? If I have a $6 fee and $25 tickets, how much is one ticket going to cost me? 30. Did everybody agree? $31?
Yeah.
How much would two tickets cost me? Am I going to have to pay that $6 fee every time?
No.
How many times do I have to pay that?
One.
Once. And from then on, every ticket is how much? $25, right? So if I was to put this in a table form, okay, one ticket costs me, I'll do this up on the whiteboard. How much does one ticket cost me? We already figured it out, right? One ticket is $31, right? Why? What does this mean? This is $6 plus what? Okay, so how much does two cost me? I'm not going to add 31 to this. How much am I going to add to that? What's that going to be? 50, 56. Three, how much is three tickets going to cost me? What would I do here? Add 56 plus what? Okay, so let's do that. 56, 66, 76. How much? 81. Okay, how much is four going to cost me? 106. Okay. Do you see how we filled out our table there? Now, is this proportional?
No.
No, and the reason it's not proportional, guys, if you were to flip it over, okay, and say 1 over 31, does that ever equal 2 over 56? No matter what, those can never equal each other. If I was to find my cross products, what's 1 times 56? What's 2 times 31? Do those equal each other? No. So that's not a what? That is a non-proportional relationship, isn't it? Okay, does that make sense how we figured that out? Okay. All right, look at this one. And let's see if you can tell me. Does that make sense? It's not that difficult, is it? All right. The Vista Marina rents boats for $25 an hour. Easy enough. Okay. In addition to the rental fee, there is a $12 charge for fuel. The table shows the amount paid for 1, 2, and 3 hours. Okay. So 1 hour costs how much? Why $37? Because we had to pay what? $12 for fuel. But why did it only go up to 62 on the next one? Because we didn't have to pay what again? The fuel. Okay, so is there a proportional relationship here? If I was to ask you to prove that to me, what would you do? Can I make this into some ratios? 1 hour is how much? Okay, what about 2 hours? Okay, how can I use this to determine if they are proportional? Cross products. What's 1 times 62?
62.
What's 2 times 37?
72, grade 74.
74. Do those equal each other?
No.
No. That's easy, right? Right? Okay. Now, the next thing we're going to find the constant of proportionality. Okay? Now, think about what that means. What does constant mean? Something that happens over and over again, right? Okay? So we're going to have some information here. Okay? Let's look at this information. Okay, the winner of a jump rope competition jumped 124 times in 20 seconds and 186 times in 30 seconds. What is the constant of proportionality? Well, what do you think we're going to have to find here? How many times she what? How many jumps in per second, right? So what can I do with these two numbers?
Divide?
Divide. So if I divide, I can figure, am I finding a unit rate again?
No. Well, yes.
If I want to know how many she's jumping in a second, am I finding a unit rate?
Yes.
I am, right? So how many does she jump in a second? 124 in what? 20. Okay. Well, can 20 go into 12?
No.
Can 20 go into 124?
Yes.
How many times?
6.
6. I have a 4. Can 20 go into 4? Add a what to what? Decimal into 0. How many 20s go into 40?
2.
Okay, so according to this, she jumps 6.2 is it jumps
Yeah.
per what?
Second.
Per second. Now, is that a unit rate?
Yes.
We have this simplified down to a single unit, don't we? Okay. Let's take the other one. Let's see. 186 divided by 30. Well, how many 30s go into 180? 6. Do you guys agree? Okay. So 6. What's 30 times 6? 180. What's left? 6. 30 can't go into 6. What do? Decimal and a.
0.
How many 30s go into 60? Is that the same as that?
Yes.
Okay. So according to this, what is the constant change? How much is it changing? In other words, what's the unit rate? Sorry for my previous. What's the unit rate? 6.2 jumps per second. Okay, so my constant, the constant change every second, how much does the amount that she jumps change? 6.2, right? So if I said she jumped for 2 seconds, could you figure out how many jumps she had?
Yes.
12.4.
4.
Okay, does that make sense? Yes?
Yes.
Okay. All right. Try this one. Let's see if we can get it right. Try this one on your own. Write this in your notes.
Are we gonna have any online things for homework?
Eventually, yeah. All right, somebody read that to me. What does it say? So are we determining if this is proportional? We are what? We've been told it's proportional, right? According to the number of wristbands. So what can we do here? Can we divide this? All right, so let's do this. Good old-fashioned long division. I know, it makes you excited, doesn't it? Okay, 163.80 divided by, how many did we divide? 420. Okay, first thing I should deal with here is what?
Cross out the zeros.
This, right? Can I move it up? Okay, so what does that put us up? Puts it up there, right? Okay. Do I even have a decimal here anymore?
Nope.
No. Okay, how many 420s go into? Tell me to stop when it can go into. Can a 420 go into 16?
No.
163?
No.
1638?
Yes.
Hang on, I know what you're gonna say. Just give me just a second. How many 420s go into 1638? 3? You wanna try 3?
Sure.
All right, let's try 3. Who said 4?
What is?
Wanna try 4?
No, there's too much.
Can I do this in my head? What's 400 times 4? 1600. What's 20 times 4?
80.
1680. Will that work? Won't work. So what's going to be? 3. Let's do this in our heads. What's 400 times 3? 1200. What's 20 times 3? What's 1200 plus 60?
1260.
Okay, so we did that in our heads. Okay, so what do? I subtract, so I have 4. Sorry, I can't do that. So 8, and then 5. What's 13 minus 6? 7, 78. Okay, bring down my 0. How many 420 is going to 1,780? What do you think?
4.
You think 4?
4.
I think 4 will go in there.
Yep.
Okay. So now let's do 420 times 4. What's 400 times 4? 1,600. Okay. And 20 times 4? So what's that going to be? 1,680, right? Okay, so that's 4. So let's look at our answers here. Okay? Which one of these looks like we can get to the same unit rate, do you think? You think B? Okay. How would we figure that out? Jacob?
No, I have a question.
Sure. What is your question?
I don't know if this is a bad question or not, but, wait.
There's never a bad question.
Wouldn't there be a 3 instead of a 1?
Probably. We probably did something goofy there. I'm just going to divide it real quick and see what we get. 420. Yeah, it should be 39 cents each. We did mess it up. So if they're 39 cents each, how can I use, which one of these would go down to 39 cents each? What can I do there? Divide the money by the, could I do this with the calculator probably a little faster? Yeah. Okay, so let's do that. Let's try it. Okay, let's do the first one. 31.20. You won't have to. I'll let you know if you need them. Okay, divided by 80. Okay, the first one is 39 cents each, right? Okay, let's do the second one. 150.80 divided by how many? 520. That's 29 cents each. So is that one proportional? No. The third one is 126 divided by 315. That one's 40 cents each. Okay, so which one is it going to be? What's our answer going to be? A. But because that one equals 39 cents. Okay. Does that make sense? Okay. All right. Let me look at your assignment.